Welcome back to another video. Dr. Tarcia Huber here, and in this video we are going to learn some new identities, specifically the sum and difference identities for cosine, okay? And for the sake of time, I'm not going to go through and show you how to derive those. I'm just going to show you what they are. Alrighty, so here we have the sum and difference identities for cosine, okay? So cosine of A plus B is equal to cosine of A times cosine of B minus sine of A sine of B. So whenever you're taking the cosine of two angles being added, or you can break up the cosine into two angles being added, then that's equal to the cosine of the first angle times the cosine of the second angle minus, so notice the sign switch, the sine of the first angle times the sine of the second angle. And so vice versa, if you wanted to do the cosine of two angles being subtracted, then it'll be the cosine of the first angle times cosine of the second angle plus, again, the signs are different, the sine of the first angle times sine of the second angle, okay? So this is a new identity that we have, and so we're going to go through and use this identity, okay? So for the first example, we want to find the exact value of cosine of 15 degrees. Now this sum, or these angle identities, sum and difference angle identities for cosine, they are really good for finding the cosine of angles other than our special angles. Remember, our special angles were 30, 45, and 60, and 90, and then all of the coterminal angles to those, or angles that have those as reference angles. So for example, this one we want to find the cosine of 15 degrees. 15 is not one of our special angles, but we can get to 15 degrees by using two of our special angles, okay? So we can say that cosine of 15 degrees is equal to, that's cosine, the cosine of, so we can use two of our special angles. We can use 60 and 45, or we can use 45 and 30, right? That's 45 degrees minus 30 degrees. So we can rewrite the cosine of 15 as the difference of two angles. Or we can rewrite 15 degrees as the difference of two of our special angles, alrighty? And so now we can use our difference angle identity for cosine. So this would be equal to the cosine of 45 degrees times the cosine of 30 degrees. Remember the sign changes, so plus the sine of 45 degrees times the sine of 30 degrees. And so now we know the cosine of 45 is the square root of 2 over 2. The cosine of 30 degrees is, what is that, square root of 3 over 2. Sine of 45 is square root of 2 over 2. And sine of 30 degrees is 1/2. And so now we just simplify that. Square root of 2 times square root of 3 is square root of 6 all over 4. Square root of 2 times 1 is square root of 2 over 4. And if you combine those, because they have the same denominator, that'll be the square root of 6 plus the square root of 2 all over 4. And so that is the exact value of the cosine of 15 degrees. Alrighty? So look at that and let me know if you have any questions. If so, you can include them below in the comments. If not, let's go to the next example. Example 2, we want to find the exact value of cosine of 5 pi over 12. So now for this one this angle is in radians. And so for me, in order to be able to rewrite 5 pi over 12, I know it's not one of my special angles, but to rewrite it using some of my special angles, I like to convert it to degrees first. So remember, to convert from degrees to radians, you multiply, or from radians to degrees, you multiply by 180 over pi. And so if we multiply 5 pi over 12 by 180 over pi, we end up getting, so 5 times 180, because the pi's cancel, and then divided by 12, we end up getting 75 degrees. So this angle is 75 degrees. Okay, so I had to erase that. This angle is 75 degrees. All right. So now I know that I could rewrite the cosine of 5 pi over 12, or the cosine. So now I can say the cosine of 5 pi over 12, that's equal to the cosine of 75 degrees which is equal to the cosine of 30 plus 45. So I'm using two of my special angles. Well, now I can use the sum angle identity for cosine. So that would be cosine of 30 times cosine of 45. Remember the sign changes, so minus, and that's degrees, the sine of 30 degrees times the sine of 45 degrees. Alrighty, that's 30 there, y'all. I know my writing is looking bad. Again, that's because my screen is going out on my computer and I need to invest in a new computer. Alrighty, so cosine of 30 we know is the square root of 3 over 2. Cosine of 45 is the square root of 2 over 2. Sine of 30 is 1/2, and sine of 45 is square root of 2 over 2. And so square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1 times square root of 2 is square root of 2, all over 4. We can combine those because the denominator is the same. And we get square root of 6 minus square root of 2, all over 4. And that is our final answer for the cosine of 5 pi over 12. Or you could say the cosine is 75 degrees. It looks really similar to the last one, the 15 degrees, except the only difference is here there's a plus sign instead of a minus. And so that's how you would find the cosine of 5 pi over 12. Let me know if you have any questions, okay? Let's look at the next example. Now we want to find the exact value of cosine of 87 degrees times cosine of 93 degrees minus sine of 87 times sine of 93. Now, to me, I can look at this and see that this looks like the one of the sum or difference angle identities for cosine, because we have the cosines being multiplied and we have the sines being multiplied, and then there's a minus in between those. So if I use one of the cosine angle identities, if I go back to them, it looks like this first one here because the minus in between them. So that would be equal to the cosine of the first angle plus the second angle. So this is equal to the cosine of the first angle, 87, plus the second angle, 93, and that's degrees. That's what this is equal to. And so what's 87 plus 93? 87 plus 93 is 180. So this will be equal to the cosine of 180 degrees. And we know that the cosine of 180 degrees is -1. All right, the cosine of 87 degrees is -1, and so -1 will be the exact value of this problem. All righty, hopefully that made sense. Let me know if you have any questions. If so, put them in the chat below. And let's go to the next thing. So now we've talked about the cofunction identities before. We talked about them, but we're bringing them up again because when we talked about them before, we only used degrees. But now, since we've been introduced to radians, those same functions apply, but this time we can use radians as well. And so I'm just going to show you an example because we've done these before. I'm going to show you a quick example of how to use it if your angle is in radians. So for this example, we want to write the cotangent of 9 pi over 10 in terms of the cofunction of a complementary angle. So first of all, we have to remember that 90 degrees is the same as pi over 2 in radians, okay? So we have the cotangent of 9 pi over 10. And remember, the cofunction to the cotangent is tangent. And if you don't remember, you can go back and look here. So cotangent and tangent, you see they're shared here. And then cotangent and tangent, they're shared here. So we have cotangent of an angle. So cotangent of an angle is equal to tangent of 90 minus that angle. So this is going to be equal to the tangent of 90 degrees, but since it's in radians, we're going to use pi over 2 instead of 90 degrees, minus that angle, 9 pi over 10. So basically, we need to figure out what is pi over 2. We need to figure out what is pi over 2 minus 9 pi over 10. In order to subtract those, we have to have a common denominator. Our common denominator is going to be 10, so I will multiply the top and bottom of pi over 2 by 5. And so that ends up giving me 5 pi over 10 minus 9 pi over 10. 5 pi over 10 minus 9 pi over 10 is a negative 4 pi over 10. And so now if we reduce that down, that reduces down to negative 2 pi over 5 because 2 goes into both the 4 and the 10. And so if we rewrote cotangent of 9 pi over 10 in terms of its cofunction of a complementary angle, remember complementary means the angle sum up to 90 degrees, then we would get tangent of negative 2 pi over 5. All right, let me know if you have any questions about this one as well by including your questions in the comments. All right, and one last example is we can also verify some new identities that involve these these sum and difference angle identities for cosine. So usually we start with the most complicated side, which in this case, it would be this side. However, I now see that here I have cosine of 2x, which is actually a sum identity for cosine. So if I see that I can use an identity right off the bat, then I want to start with that side. So for example, or what cosine of 2x is, cosine of 2x is the same as cosine of x plus x. That's what 2x is equal to. So all I did was rewrote the 2x as x plus x. Well, now I can use the sum identity for cosine. So this will be equal to cosine of x times cosine of x minus, remember the sign changes, sine of x, the first angle, times sine of the second angle. Well, cosine of x times cosine of x is cosine squared x, and sine of x times sine of x is sine squared x. And that's what we were trying to show. We were trying to show that cosine of 2x is equal to cosine squared x minus sine squared x. So that is how you will verify this identity. Remember, you start with one side to show that it equals the other side. And so usually I would start with the right side because it's more complicated, but now I see that I can use this sum angle identity over here by adding the two x's together. And by using that identity, it takes me right to where I need to be. And so the justification for this step again, or the justification for this step, is the sum angle identity for cosine. And then for this last step here, all we did was simplify. Alrighty. If you have any questions whatsoever about these identities, don't hesitate to put them in the comments below. If this video was helpful to you, go ahead and hit the thumbs up button. And if you haven't already, go ahead and subscribe to my channel. Thanks again for watching, and I will see you all in the next video.